Hi there once again and welcome to another Expresso mechanic tutorial. And this is the 11th in the series Expresso Nuts and Bolts. In this one we're going to be taking a look at the order node. Now this is a node I've never used before, but it's actually quite an important and useful node because as you're seeing on the screen it actually enables us to deal with three entirely different scenarios. That's its purpose. That's what we're going to be about in this tutorial, so without further ado, let's see if we can make this happen. I'm actually going to show you three different setups for achieving what we're about to do here. So in our first setup, we've got quite an involved expression here. What we've got our sphere and our cubes position wise, and we've plumbed these into two compares. Now in our first compare we're saying, is the sphere's position y greater than that of the cube? If it is the case, we're going to switch this condition and we'll output a 0. And the 0 will then be used to switch this condition. Now the first input is sphere is higher, so that's what we'd expect. And this is set up with obviously three strings. So these strings are going to be passed to the text line. So at the moment both are equal is lit up here. And that's what we would expect if the two of them were both at the same point, which if we check their heights, we're both at 0. So that's fine, that's working okay. Now our second scenario here, we are in fact checking to see if they are both equal to each other. And if that's the case, our condition here will be switched to input 2, which will output a 1. This will pass straight through this condition because of course this is not satisfied here, so this will be set to input 2. So this is going to pass through here and go to our switch, and it will give us the second string because of course both are equal. So we're going to be getting the string at input 3 because of course these are labelled 1, 2, 3 and 4. So this is working fine and we're getting exactly what we need at the text spline. And then finally we've got another scenario here, which of course if neither of these are satisfied, then we get the value that's at input 1 here, which is a 2. So the 2 will pass through this condition and it will switch to the fourth input, which is cube is higher. And that's the only scenario that remains. So what we've got here then is an if along with an elif else scenario. That's what we've got. So if, elif and else. We've covered those three scenarios with two conditions. And that's all very fine. This is a good expression and it does the job. It works perfectly well. But the problem with it is that it's perhaps a little bit too clever for its own good. And it's, I wouldn't say it was cumbersome, but it's certainly quite a deep expression. And it's something that you're going to set up if you've got expert knowledge with Expresso, really. And it's a little bit too clever, as I say, for its own good. And it uses 8 nodes, which is actually quite a few more than we perhaps need to use. But anyway, that's our first scenario taken care of. Let's check out our second scenario. Okay, so this is a little bit different, isn't it? We've got still the cube and the sphere here with position y. We've got those two which are the same, but everything else is well, changing quite radically, isn't it? The only other thing we've got is the text spline, and we've replaced everything else with one Python node. So let's just open the Python editor and just see what's in here. Well, what we're doing here, we're using the same scenario. If I just click on this again, just to bring this back, what we've got, if we imagine these 4 nodes here as code, that's what we've got here. These lines of code are doing exactly the same thing as these 4 compare, or the 2 compares and the 2 conditions. And of course this condition here, because this is not being used either. We don't need to use a condition with strings in it here because we can just set things up in the Python node as strings. And if we just click on this result here, if I just hover on there, it says the result is a string. So I've set that up as a string output. So I don't need that final condition node. So yes, what we've got here is if the cube's position y is greater than the sphere's position y, we output cube is higher. If the cube's position y is equal to the sphere's position y, both are equal. And then else, it's got to be sphere is higher because it's the only option that's left. So it's exactly the same, as I said, as what we did before with our first scenario, just in code. And okay, that's fine. We've only got 4 nodes here this time, so half the number of nodes. And you think, well, this is obviously the scenario to go for. But what you've got to remember is that this is not as straightforward as it perhaps seems, because I've had to set this Python node up. I've literally had to, well, I didn't have to, but I chose to rename these 2 ports. This port here, I got rid of the original output, and I've had to replace it with a string output, and then I've renamed it result. And then, of course, I've had to go into the editor over here, and I've had to key in the code. So, you know, there's quite a bit of work to do to actually get this set up. But it is quite elegant, and it's, you know, minimal number of nodes, so it's not a bad setup. But there is that extra piece of work that you've got to do with the Python node. So let's have a look at our third scenario. Well, at the moment, there's nothing in this particular Expresso expression here. But what we're going to do is build this one from scratch. So I'll grab a hold of my cube and my sphere, bring those 2 in, set them up, and at the output stage, I'm going to give them position Y ports as we've done with the others. Just make them a little bigger so that we can see what we're doing. If they will, thank you. Thank you. Right, okay. And then the next thing to do is bring in the all-important order node. Now this hides under the logic menu, so it's down here, the order node. Just bring that one in. And let's have a quick look at it. Well, it's one of those nodes where you can't add anything and you can't take anything away. It just is what it is. So we've got 2 inputs, 1 output, and we can plumb our position Y outputs into our 2 inputs there. And at this output port, let's just get a result node and see what this is doing. So we'll plumb this in here. Okay, so at the moment it's outputting a 0. And it does this when the 2 inputs are equal. If we select our sphere, and at the moment, as we've said, we can see that the 2 are absolutely equal. If we make the sphere lower, we get a 1 at the output, because the initial input, or input number 1 here, is the greater value. So if input 1 is greater than input 2, we get a 1, okay? If we move our sphere back, they're equal again, and if we go the other way, so the sphere is higher, we now get -1 because input 2 is greater than input 1, and that gives us -1. Now this numbering system doesn't really help us at the moment, because if I just go back into my original scenario here, what I need to do is select both of these, and I'll copy them, come back into here, click and paste them in, and just leave them. Well, I can bring them over here actually. So what we need to do, I mean, -1, 0 and 1 isn't really going to help us with this, because we need 0, 1 and 2. So the way we can sort that out is perfectly simple. We can just bring in a math node, calculate math, and it's a math add that we want. We'll just plumb that in there and plumb this into our switch. And then all we need to do is make the value for our input 2 1. And that gives us the result that we want, because now -1 has become 0, and obviously 0 has become 1 and 1 has become 2. So that's given us what we want. So this is our final node for this particular setup. That's what it looks like. We just need 6 nodes for this one. And it was minimal work. I mean, it hasn't taken me long to set this up. Now let's see where we are. So this is actually plumbed in and it's all working. It's ready to go. These 2 are both switched off, so they're not going to be doing anything. So let's see what happens. And at the moment it says both are equal. Perfect, because that's where I started things. So let's just run the timeline. And now our cube is higher. Both are equal. Our sphere is higher. So that's working perfectly. So you can see the value of this node. If you've got a situation where you've got 3 definite scenarios that you need to differentiate between, this node is the one to reach for. It'll be your new best friend. especially if you don't want to use code. I mean, personally, I might have well have done the Python coding. That's to me is the most simple solution. But if you don't want to do code, or you don't know anything about code, and you're not interested in knowing anything about it, and I don't know why you wouldn't be. I mean, you know, surely you've done my Python Bytes course. But if you haven't, I'll put a card up and you can take a look if you want to. But seriously though, if you don't want to do anything with code, then this node is a fantastic friend to have in a situation like this. That's what I wanted to show you in this tutorial. And that pretty much draws it to a close. I hope you've enjoyed this one and that it's given you some further insight into Expresso and perhaps some ideas for your own projects. And if you have enjoyed the tutorial, then please give it a like, and of course, if you haven't already, please subscribe to the channel, leave a comment, and of course ring the bell. And wherever you happen to be on social media, then please share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that about brings the curtain down on this one, so I'll see you very soon on the next tutorial.